Hello, wonderful people of the internet. Welcome back to another episode of Simuleos. Let me go ahead and turn down the music on my side just a little bit. It shouldn't turn down the music on your side. Let's see, what do we have here? Redu, Gathros, Uncle Bill, thank you guys so much for coming in. Really appreciate it. Alright, so today, we are going to be working on the fractal stuff. Today should be... So here's the thing. I'm actually not sure how today's going to go. Because I spent some time yesterday, after work. I was kind of working from home yesterday, but even so, I still had a lot of work to do. And so I wasn't able to start doing the voice recording until about maybe 5 or 6 in the afternoon, which sounds fine. But unfortunately, I wasn't able to get the voice recording to sufficiently high quality last night. So I was like, all right, well, fine. I'll go to bed early at like 7 or so. And I'll get up early, and then I tried to do more voice recording this morning, and I just couldn't get the voice recording done. I don't know what the deal was. It just wasn't working. So it's going to be very hard to get a video out tomorrow. I think we can still push it. I think we can still get it out tomorrow. But it made me question some things last night when I was thinking about what we should do with this video, and I kind of wanted to talk about that a bit. Sorry I don't get by more often. Then I might actually know what fractals are. Let's see. It's fine. Fractals. Yeah, see, this is actually a good point. Let me go ahead and get some water real quick. Here it is. And then we can start talking about it. Gathros has a Simu account in the chat. Times 7. Over 7. What does that mean? James, haven't gotten emoji fonts? I have not. I should. But hey, you know how it is. Sometimes you just want to use an old school terminal. I'm going to go ahead and put a Simu account in the chat just because I saw one before. Thanks, Gathros. Cow. Yeah, so I do have quality options today. Also, okay, yeah, I had to refresh my notifications real quick. Okay, the 7 is a typo. Oh, okay, I see. Misunderstood. I thought for some reason there was like a subscription that I missed or something like that. I was like, oh no. But no, it doesn't seem I did. Okay, so let's go ahead and talk about where we are, where we've been, where we're gonna go, all that kind of stuff. So I'm gonna just go ahead and CD into projects, Simuleos, and Fractal, and we're gonna do the same thing over here. CD projects, Simuleos, and Fractal. Let me do a quick MPV. Okay, so here's the Barnsley fern as we generated it last time. Again, it's just a fern with ferns on top of it, all that kind of stuff. We tried to do a visualization where we basically took a random number of points and we showed basically what each component of the Barnsley fern does, right? Because essentially, this fern is composed of 4 different parts. It's got a stem, it's got a right leaf, a left leaf, and then it has a recurring set of those leaves forever and ever until eternity, right? So the question is, how do we generate these objects? And the answer, I guess, is kind of simple, right? So we have a stem that's one transformation, right? We transform all of our points to move to the stem, which is literally just multiplying them all by 0 in x and some value in y to force them all into a single location in x, right? Then after that, we have another transformation that moves them this way, another transformation that moves them that way, and then finally a transformation that copies them upwards and slightly rotates them and moves them to the right. And that's the whole fern. That's all it is. Now, I showed a visualization of each of these transformations. It kind of sort of made sense, but quite frankly, I would like for it to be a bit better. And that's true also for the Sierpinski triangle animation that we also generated. Let me go here and let me just run /Sierpinski. Because this video also has some stuff that we want to work on. What file manager do you have? I mean, I can use multiple file managers. I think the one I use most frequently is PCman FM. PCman FM. I think this is the one I use most frequently. But quite frankly, I also use Nautilus or whatever else. I have a keybind for Command F. Sorry, Super F. And that's what I use, and it's, I think, PCman FM, so that's the one I use most frequently. But it doesn't really matter. I don't think it matters too much. What actually is the difference between the file managers? I mean, I know PCman FM, this one's pretty quick, but Nautilus, I think, has a few more features. I'm not really sure. I don't really know. I should try NNN. Yay dash SNNN. Yes. NNN. I had one like this before. Is this one that we can check the images? Oh, no, it's slightly different. Put here. There was also one called Ranger. Let me see if I can do pacman-s ranger sudo. Yes. So this was also a fun one, Ranger. Yeah, so it opens up everything. And I think some of them, maybe this isn't the one I was thinking of. No, but some of the terminal package managers, some of the terminal file managers, that's what I'm looking for. Some of the terminal file managers will actually like show the images that you're looking at in ASCII. It's really fun. In fact, I'm surprised I thought it was this one, but maybe I'm wrong. What do we have here? MCFTW for console. Hey, Trash Talk. Let's see. To edit P, to preview, Vim keybinds to move. Oh, okay, well, let's try that. NNN. And you said P to preview? I guess you can't preview a, let's try this guy. Okay, nice. Nice, that's pretty good. So let's take a look at the Sierpinski triangle, MPV. Okay, so here's our image of the Sierpinski triangle that we had also generated yesterday. So I like the animation. I think the animation is fine. It's rather straightforward. However, I would like to basically update this animation so that it kind of tells the story of how to generate the Sierpinski triangle to begin with, right? So basically, I would like it to say, okay, we start with our 3 initial points, 1, 2, and 3. Then I'd like to generate a single point and say, all right, well, this single point, you know, has now an option between 3 different branches. Move towards one triangle, another triangle, or another triangle, right? So it moves over here. Then at that location, and it then has another choice to move between the 3 branches. And by moving again and again and again and again, eventually, you know, we get the Sierpinski triangle. So I want to show basically the arrow being drawn. I want to say, okay, well, we have this point here, and we have basically this location, right? So it has a choice between 1, 2, 3, and then it moves this way. And the next one has a choice between 1, 2, 3, and it moves this way. And then so on and so forth. And then eventually we just show the whole triangle being generated, right? Like I want to show an animation that shows people what's happening. And this animation just doesn't quite do that because of the way we have to generate all the points. And I think the same is true for the Barnsley Fern animation. It doesn't really clearly show what's happening. And I'm not a big fan of that. I'd really like for these animations to show a bit more. And so that's kind of where we're at, right? Like, sure, we can put these into a video, and we can make a video on all this kind of stuff, but also I just made the script for the next video, and let me show you something. In order to properly explain what it is that we're doing with these fractal Christmas trees, which honestly we have very few of, I have an entire page and a little bit more talking about just fractals. Then I have just this little section here talking about the fractal flame method, right? Because honestly, once you understand the iterated function systems, fractal flames are relatively straightforward to understand. It's just a combination of a bunch of other, basically IFS systems. So that's what kind of got me. I realized that even though this was supposed to be a Christmas-themed episode, there's literally nothing about Christmas in this episode. It's just like, oh, hey, Christmas trees, you know? And so it kind of fits anywhere, like we can put it anywhere. And I figured, why am I rushing to get this out before Christmas if it's not even really much of a Christmas-themed video? You know, I still want to see a Christmas tree. Don't worry, like, I'm still working on it. But like, yeah, kind of made me think, why am I rushing to get this out before Christmas if I could instead get it out after Christmas or even at the beginning of next year when I have some time over this upcoming week to work on a really good chapter for this, you know? So let me go ahead and open up Cal. Right now we're on the 22nd of December. There we go, 22nd of December, right? Which means Monday, here, the 24th of December, I've got off for the Emperor's birthday, and I'm intending to use that time to go ahead and do the revisions for the Quilly-Tukey method. Now, like I said, revision is necessary on almost all chapters, but I'm actually not a fan of bacon. I know that sounds really weird, but I've never really been a fan of bacon. Like, it's okay, but I could very easily cut it out of my life and I wouldn't have any negative consequences. I don't know, like, don't get me wrong, like, I understand people like bacon. It just wasn't ever my thing. It's kind of like chips. I don't get chips either. Anyway, it doesn't matter. Point is, I will have the 24th off, and I will be using the 24th basically to stream algorithm archive updates, all that kind of stuff. This entire week, is going to be mostly available. I mean, don't get me wrong, I still have to work during that week, but I'm not planning to work overtime that week. I think this week I'm just going to kind of take it easy, you know, get stuff done, but not force myself, you know? I don't know what crisps are, so I mean chips. Anyway, so we have this week, and I'm going to be working, but kind of taking it easy. Now, the thing is, Cal 2019. At the start of 2019, I had the first 3 days off, which is great, because that means that I can use this time to basically, you know, completely revise the algorithm archive. I can use the time to work exclusively on the algorithm archive content, and I can get a good chapter out, which would mean that we could probably get a chapter or a video on fractals out on Sunday the 6th. That's literally waiting 2 weeks for this video. It won't be so bad. And on top of that, I could even do a video out on the 30th of December, doing one more Contributors Corner, where we talk about all the stuff that happened during Hacktoberfest, all the cool updates and stuff that's going on, discuss like what the plans are for 2019 and stuff like that. Now, I don't mind doing this, right? Because I think I really should start sticking to the schedule of every 2 weeks putting a video out, right? And so I'm already breaking that if I put a video out next week, you know? So I'm thinking what we might do instead. I'm thinking what we might do is we might hold this off until January 6th, or maybe even January 13th, depending on whether we put a Contributors Corner video out on the 30th. And that might be what we do. That way we have a chapter to go along with it. We're not breaking our motto of the algorithm archive first, and we get everything. Yeah. I mean, that's how it is, right? I can use my 3 days off to work. I mean, this is how this project goes, you know? I just don't have time to work on it except for when I'm off, you know? So that's how it is. And again, I would love to be able to incorporate this into my job, but it is what it is. Data or data? I mean, I know you're saying data or data, but I don't know. If you're referring to American bacon, I understand that. It's far too fatty. I'm also a vegetarian, so, you know. Let's see, what do we have here? Yeah, about that, about www.algorithmarchive.org. I found earlier on stream you made with this. Nice. I assume you mean that you found out that we're making that. Yeah, that's our primary project, the algorithm archive. And I've been kind of ignoring it for the past month, just because I'm just out of time, you know? Skill 9-7, hey, let me get some more water. I don't know what the deal is, but my mouth is just super sticky today. I'm a what? I said vegetarian? Is that honestly a big surprise, or is that surprising to anyone? Like, I thought it was pretty clear. I make this distinction a lot, so... I know you're a vegetarian. My shoes weigh more than you. I don't know what that means. I always thought light on your feet meant that you were gay. I didn't think it meant you were not valid. I didn't think it meant that you were vegetarian. I mean, don't get me wrong. Like, I mean, I don't know. But relax a bit those 3 days. Yeah, honestly, that was also why I kind of wanted not to put a video out this weekend. I'm going to be killing myself today to get the video out tomorrow. And you never said you're vegetarian? I definitely have before, but I do apologize if that's offensive to you, because I'm not trying to offend anyone. It's just, I don't know. I'm definitely not, I'm not like a closet vegetarian or anything. I'm sorry, it's not like it's a huge revelation. It's just like, come on, it is what it is. I'm sorry, I didn't mean to be hiding this from the community or anything like that. I mention it a lot. A lot of my friends are Indian, South Indian, and there's a very large number of vegetarians there. I don't know, like, it's just a lot of my friends at some point became vegetarian, so I just stopped eating meat. Just, I don't know, out of solidarity, I don't know what it was. I just stopped eating meat, and now I have trouble digesting it, so I just don't do it anymore. I'm just shocked after more than a year, I never knew that. It is what it is. I'm sorry, I mean, again, I'm not a closet vegetarian, but how many situations come up where people are talking about bacon in the chat, and then they're asking, why don't you like bacon? It's like, oh, I don't like bacon, you know, I just never really liked it. And I guess no one really asked that, did they? I guess I'd still just offer my opinion up without anyone actually asking, hey, do you like bacon? And I was just like, not really. Interesting. I was offering my opinion up without anyone. I mean, it's not as bad as being vegan, but like, I still guess I probably shouldn't have mentioned that I'm vegetarian there. Like, there was no real social reason to do so. That was my bad. Anyway, as far as the schedule is concerned, what do you guys think? I think it's better to focus on quality than quantity, especially at this point. That's always been my motto, focus on quality over quantity. And in my opinion, one of the main things that we give that other people don't is the algorithm archive, you know? And so if we're making a video on fractal flames, on iterative function systems that doesn't have an algorithm archive chapter to go with it, when an algorithm archive chapter does need to be written, it seems like we're doing something suboptimally, you know? So here was my plan. And again, this might be a dumb plan. Personally don't like bacon too, no need to worry. Good, I'm not the only one. But yeah, so my plan was potentially put a contributor corner video out on the 30th. And in this contributor corner video, I want to discuss all the things that we did over Hacktoberfest, because we're currently missing a lot of stuff there. Talk about all the stuff that we've been working on, we will be working on, talk about the revisions that are currently going on, talk about all this kind of stuff, chapter submissions, all of that kind of stuff. Then I also wanted to discuss some, I guess you could say, community, I don't know how to put it, community stuff. It's just like events that we could do together. So, I would like to start doing these community challenges a bit more frequently. Not quite like what we did with the fractal Christmas tree thing. I think something kind of a bit bigger, you know, like, I'm not really sure what to do, but like, some sort of challenges that we can do together as a community where we all kind of work together to try to figure something out. And that's going on. What's happening with my chapter? As far as the chapter is concerned, it's there. We're working on the revisions, but the issue is that we need to do a few more revisions first, which I'm going to, I promise, I'm going to do my best to make sure that after these 3 days are up, after I am done with the vacation this year, and after I've spent the time working on the algorithm archive, that after that point, chapter submissions will be basically be merged into the algorithm archive. That's my point, or that's what I hope. Because honestly, we're running into a bit of an issue with the licensing, but I think we found a solution to that. We just have to implement the solution. I would like to finish up the Cooley-Tukey method, and I'd like to add some more references to Gaussian elimination and a few more things here and there, just to make sure we have good, high-quality chapters to work with, and then we can start updating everyone else. Updating everyone else's chapter that they submitted with animations and all this kind of stuff. So there's a lot of stuff to be there. You can like bacon and still be vegetarian. What's impossible with that? It's not like you were vegetarian from the baby stage. Yeah, that's true, but like, again, even as a kid, I just didn't like bacon. Like, meat was always one of the things that, don't get me wrong, like, it's tasty, but it wasn't like ever the tastiest thing on the dish. Like, I used to like meatloaf, not because meatloaf itself was good, but because it always came with cream corn, and cream corn plus meatloaf was really good. It's always the combination of meat and something else that makes it really good. And if I had a choice, I would usually eat the something else over the meat, you know? It was kind of like, you know, you'll eat rice or you'll eat potatoes. These are okay, they taste good, but they taste really good in combination with other things, you know? And that was my opinion with meat. It's like, well, I mean, if I can just cut out the meat, that's like cutting out the potatoes or cutting out the rice. You're just cutting out the carbs. You're cutting out the stuff that doesn't taste as good, you know? And unfortunately, like, I know, like, looking back, that's probably poor, like a poor reason to do so, but it is what it is, you know? Anyway, I'm not going to talk about me being vegetarian anymore. What I want to hear is your guys' opinion on the schedule. Like, how destroyed are you guys inside if we don't make a video tomorrow? That's my question. Like, are you guys okay if no video comes out tomorrow? We just put a video out last week. I think maybe we're okay not putting a video out tomorrow. Trash Talk, I have not seen that video. I wasn't able to be on YouTube yesterday. I was just working too hard. I didn't have enough time for literally anything. And that's what I'm saying. Like, it's just too much work to get it done tomorrow. Ah, man. And I know that's super unfortunate. Why am I waving a Japanese fan? Like, I don't understand. What am I doing with this thing? No, I hadn't been able to see it. I saw on Twitter that he posted it, but I wasn't able to actually look at the video yet. But, I mean, all of their videos are very, very good. I met one of the people in the Kurzgesagt team at ThinkerCon, so it was kind of good. Let's see, I wonder what JSPP thinks of the vegetarian thing. I think he already knows. I don't know. I find it weird that you're just finding out now. I really am finding that a bit weird. Okay. So yeah, I think that's the current schedule. And again, I apologize that means we're not going to get a video out tomorrow or before Christmas. I know that sucks. but it's just a missed opportunity if we don't get that algorithm archive chapter out with this iterative function system stuff. Plus, I mean, I'm really just itching to write some more algorithm archive. I mean, there was a comment that was left yesterday on on the Gaussian elimination video, and it was one of those questions with like a rhetorical kind of. I don't really know. It was one of those arrogant rhetorical questions. It was like, why would I watch this instead of watching 3 Blue 1 Brown? It's like, dude, we're offering 2 completely different services here, and 3 Blue 1 Brown doesn't have a video on Gaussian elimination, so far as I'm aware. That's what I'm shocked about. Are we not friends? I mean, I consider you to be a friend. I consider everyone, I mean, not everyone here, but I consider a good number of people in this community to be close friends. I'm so sorry. No, don't get over yourself. Like, I do consider pretty much like Gathros, JSPP, Buttercake, Gastorn, like, you know, a lot of people here who do like a lot of stuff. Like, I consider you guys to be friends, and actually I consider most of the people here to show up on stream to be considered like friends. I don't know. I guess maybe it's just I don't have a social life to have real friends. I don't know what it is, but I do enjoy like almost all the conversations we've had. Like the situation where Buttercake changed, or not Buttercake, but Bergquist changed his name to Bash after ZSH came into the chat. That was the funniest thing I think I'd seen in ages. It was so funny. So the Arcane team, actually maybe the Arcane team. It was so funny. Okay, so it doesn't seem like you guys are too destroyed or defeated or sad that we're not getting a video out tomorrow, which means I can spend the time today studying a bit for iterated function systems. We can see if we can get this working on the GPU. We can start talking about like what we can do with the parallel methods section. You know, there's a lot of stuff that we can do here. And so I think what we're looking at here is probably getting a video out maybe on the 6th of January, doing some sort of community challenge on the 20th of January, so on and so forth. To be fair, you don't know my real identity, so I don't think I should be shocked. Yeah, I guess not, but isn't your name on your GitHub? I thought your name was on your GitHub. Uh-oh. Anyway, so we have January here. And honestly, even if I did know like people's real identity, and the same is true for JSPP and Buttercake and all of them, like I know their actual names, but I'm not going to actually use their names just because I like being consistent and using the moniker that they've provided to use, you know. I thought I'm not going to say. I don't actually know your real name. I'm sorry about that. I thought it was like Matthew or something, but now I'm second guessing myself. So let me just go ahead and see real quick. GitHub. You see, now I'm second guessing myself. Let me see what we have here. Algorithm archive. And then we're gonna do pull requests. And let me see real quick. Gathers down here. I swear it was on your GitHub. It's not. It is not actually on your GitHub. Okay, I was incorrect. I'm sorry about that, Gathros. I'm so sorry. I just have a suggestion of the algorithm implementations because I was just looking at a simple one, the Monte Carlo. I think algorithm functions should be the functions, not the procedures. No print lines. They should have an input and return an output. I think that's true for the most case. Let me take a look at the algorithm archive. See, this is the problem. Like, you're always going to have people who say, like, we should have one thing, we should have things look some way. Let me see. Function in circle, return X position. Yeah, I think they're all this way. Oh, you're saying with the Monte Carlo guy. Okay, fine. I see what you're saying. But here, the thing is, the Monte Carlo is the main function, so I'm kind of okay with that. But for the in circle, it obviously does that. Let me see. Let's take a look at Python. Yeah, I mean, it is the main function, right? So, okay, I see what you're saying. So Python has it returning the pi estimate and then printing it over here in the main function, which I suppose is fine. C. Yeah, I guess maybe Julia is the only one that doesn't do that then. Let's take a look at C++. Yeah, most of the other ones do it in the main function. So I guess I can update Julia to do it that way. This is also one of those things that kind of depends on... I don't know, I'm sorry. I thought it was Matthew. I was wrong. I'm so sorry about that. I don't actually know your real name then. I'm really sorry about that. This way you can export the algorithm into libraries so people can use them. Yeah, but I mean, that's not really the point, right? Like, the point is to have a working implementation that shows them everything else. I mean, where we print is kind of secondary. And don't get me wrong, like, I don't disagree. I'm just saying that, like, this is one of those things that kind of depends on the person, right? Like, having them in the function itself is also kind of nice because then it's easier to understand what exactly is going on. I don't know. It just depends, you know? I'm so sorry, Gathris. I don't actually know your first name. I'm sure everyone else does, and I'm like the only one that doesn't, which kind of sucks, and I'm sorry about that. I'm sure you told it to me too, so now I'm like sitting and thinking how to do it. Okay, you're right though. Radu, you're right. Look on the Discord user list. Is it there? Oh my gosh, I'm gonna be so sad if it's there. Discord. adev bash. I thought, okay, now I'm confused. Okay, it's not Matthew. I got it wrong. I'm sorry. I'm so sorry. What's your function name? No one knows my name. I didn't tell you. Oh, okay, fine, fair enough. I'm really sorry about that. But actually, I think I can figure out what it is. No, I think I can find out. 1 second. Oh, no, I can find out. I can actually find out your name right now if I wanted to. But I'm not going to because you didn't give anyone your name. So it's kind of wrong for me to do so. But because you sent a donation in a while ago, I could technically find your name from that. But again, like that's... If you haven't given anyone your name, then that's fine. I know, right? Like, that's why I give... This is actually why I always... like call people by their moniker instead of their actual name, because like I kind of feel it's a breach of privacy to know their actual name, but I might have slipped. Yeah, it's fine. Like everyone knows my name. This is fine. I don't mind. I think it's fine. Tell me on Discord later. Fine. I'll figure it out after stream and I'll send you a message with the name on it. I'm so sorry. For some reason this whole time I thought it was Matthew, but again, like this is fine. I'm not gonna say it on stream. I won't. I promise. But I can send you I can probably figure it out at the end of stream, but it might take like 10 minutes or so. Okay, so schedule aside, we've talked about the schedule. How sad are you guys? Just let me, I need some sort of emotion from you guys. Like, are you guys sad that we are not going to be putting a video out if we don't put a video out tomorrow? Because again, I'm gonna have to kill myself to get that video out tomorrow, and I mean that figuratively. I'm gonna have to do a lot of work to get that out tomorrow. But if I don't get it out tomorrow, we can ensure that the video has a much higher quality. It is a better, it's an evergreen video. People watch it at any point in time. Like there's a lot of stuff here that we could do just to make it really, really, really good. And we can make this chapter one of the best chapters in the algorithm archive. Like I have ideas to make it really, really good. It's just a matter of, figuring out what to do, you know, or like when to do it. And I think honestly the best idea is to wait till January to have it. Quality over quantity. Yeah, okay, most people are quality over quantity. Okay, this is fine. It's a bit unfortunate, but on the other hand, it's not so bad. Because I think now we can start working on animations and stuff for the fractals and stuff like that. So now the question is, should we tomorrow? Well, okay, let's actually keep working on this fractal Christmas tree, actually. Since it is, you know, a couple days before Christmas, I see no reason not to. Let's go ahead and get this guy going. Hey, C252, how are you? Even if the video is not coming out tomorrow, which is totally fine, I say let's just go ahead and take this Barnsley Fern code that we have, and let's modify it a bit and see what we can do to make it more Christmas tree-like, because we have a good understanding of what the Barnsley Fern is, what all the transformations do now. And so I think we can actually make this look more Christmassy, you know, if we want. And that's pretty cool. So let's go ahead and try to give this a go and see what we can do. So first of all, I'm going to modify the Barnsley Fern. You literally just missed the conversation, C252. So the issue is the following. I'm going to have to really, really work incredibly hard, first of all, to get the video out by tomorrow. And I know I cannot ensure the proper, like, the video is going to be high quality by tomorrow. Also, this video is on Fractal Flames, it's on iterative function systems, it's on stuff that really does deserve chapters in the algorithm archive. And I've just been kind of realizing that the thing that we have over other people is the algorithm archive, and I really want to make sure that, you know, we do this right. And I don't want to, I really want to be able to say that, you know, I really want to have the chapter in the algorithm archive. I really want to write it up. I really want to like get everything ready to go, you know, like, I appreciate the video content we create, but also like, this is a perfect time to put a chapter in the algorithm archive for this type of stuff. And the fact that I wasn't planning to do so is a huge oversight on my opinion. So I really want to get that chapter out, do the revisions, get everything ready to go, and then put the video out along with a chapter and stuff like that. Just finished school for the semester, headed into my final math project. Oh, dude, fantastic. How'd that go? I hope it went very well. And if it didn't, that's okay, because you always have next year. All right, so let's go ahead and go into vi.barnsley.jl. I'm going to deal with the Julia code right now. So we're very well aware of what each of these guys do now, right? So each of these transformations basically creates part of the leaf that we're dealing with, right? So what I'm going to do first is I'm going to change this to basically 0. And this to 0 here. All right? And I'm going to run this. So let's run Julia over here. And I'm going to open up another terminal. 1, 2, 3, 4. And then I'm going to work with CD projects, Simuleos fractal. Pop over here and run Julia. I'm sorry, include. And let's just include barnsley.jl. All right, give that guy a go. It didn't take too long to run. Now we're going to run new plot. Barnsley plot? No, plot Barnsley is what I'm looking for. .gp minus. All right, so here's our Barnsley friend. Okay, that didn't. Did this do what I wanted it to do? Let's go down here, G. Oh, that would explain why. I was outputting the Sierpinski triangle. All right, let's try this again. Let's go here, Control C, and now let's pop over here and run include barnsley.jl. Give it just a second to run, and then we'll take a look at it from there. Let me take a look at the code pen. New plot barnsley.gp. There we go. Okay, so what we just did is we basically removed the rotation in the Barnsley fern. So now what we've done is we made it so it all goes up towards the top, which already makes it more Christmas tree-like. Now what I'm going to try to do is move these two petals upwards just a little bit, so that we have something that's kind of in the Christmas tree shape. And then we're going to work on that in the fractal flame method and see what we can do from there. Codepen.io, let's see what we have. Osu Blake. Oh wait, what is this? Wait, what is this? It's just a flame, right? Editor view. I'm assuming this is some sort of shader that creates. I have no idea what this is. It has to be some sort of shader that's creating something that looks like a flame, right? I mean, it's super cool. Don't get me wrong. Like, yeah, that's actually really cool. Actually, I wanted to at some point create like a flame in code and stuff like that. Like, I really wish I was better at creating just like code art, you know? But I'm just not. I need to get better. Base URL. Okay, I see. So I actually don't know. Yeah, I know, it's quite good. I'm a huge fan of this. I just don't know how to do it. I don't think there's much fractal in this. It's mostly just flame. Let's see, what do we have? So I'm gonna go ahead and delete this over here. No, I'm not gonna close. I just want to close that one tab. Okay, so let's go ahead and Control C over there. So here we saw that we can just kind of move all of the branches so that they're moving towards the same point. So now let's see if we can move them so they're slightly more rotated. Let's see what we got here. So, wait a second. Sorry for the yawn. What I'm going to do is change these so that they are a little bit more rotated. So let's do 30, 30, 30, and 30. Okay. And let's go ahead and give that guy a go. So we're going to run over here, and we're going to do include Barnsley. Give that guy a second to run, and then we'll take a look at it over here. Okay, so this is already looking way more Christmas tree-like. We are definitely getting there. So let's go ahead and give it a little bit more rotation in the these directions here. So we'll change these to 40. Let's do 40. 40 and 40. And let's give that guy a go. Include Barnsley.jl. No, everyone's going to yawn. I'm so sorry. I'm bored and want something to code. Yeah, I know that feeling. See, now that doesn't look as good. I don't know what we just did, but whatever it was, that's not quite right. I'm not sure why, though. Yeah, I'm not sure what happened with that one. Wait, let's do Control-C there. It could be. Let me think. So this guy, I'm going to do some basic matrix multiplication, and let's see if we can figure out something to go with. With going with the graphics in the algorithm archive, are we going to use NuPlot? Yeah, I'm not sure about this either. That's another discussion that we need to have on the Monday stream. But I don't see anything wrong with using NuPlot. But I also don't think... but I also understand that people might not want to. And so this is something that I need to figure out. Noise is not noise. A noise or fork? What? What? What are we looking at here? Is this a troll page? What is noise? I don't understand. I don't understand any of this. Let's see. Fastest and most resource sensitive. Navigate. Okay. I just don't get it, I think. Way too symmetric. Yeah, so before we had settled on using NuPlot as the primary plotter for the algorithm archive, just because it's easy enough to output data in such a way that it outputs to NuPlot. But part of the reason that we did this was because some languages, again, like C, maybe C# and stuff like that, these languages are kind of hard to plot with directly. And so you need some way to output the data such that you can then plot it. And so if we had some sort of standard plotter, NuPlot, then we could output data in the same way for every single code so that there isn't any variety there. And we can then just plot it with the NuPlot script, and we could say you can plot like this, and that's kind of nice because then we output the data in the same way, we plot it in the same way, and now it's super easy to deal with, On the other hand, I do understand people who want to plot in their native language, like if they want to plot in Python or Julia or something like that. I do understand this. In the end, I kind of like the NuPlot stuff because it allows for consistency, and all you have to do is output the data file instead of outputting the plot. But I understand the other argument, and we can have this discussion again. I don't mind. We just need to kind of think about what we want to do with it, or like where we want to go. So let's see. What I want to do here is open up a new Zernal tab over here, Zernal, and let's go from there. I personally want to use NuPlot. Yeah, I think this was what we decided last time because it makes it a little bit simpler, but I don't know if that's the end result. Again, there's a lot of stuff that I need to do. So like this Christmas stream, this Christmas Eve stream, and also the streams that I'm going to be doing on January 1st, 2nd, and 3rd, like I'm hoping to get a lot done for the algorithm archive. Like I just want to spend the whole day just working on the algorithm archive and just getting it up to snuff, So I'm thinking, like, I'm not sure exactly how I'm going to be doing the streams, but I will be streaming a lot that day, I might take a break for, like, breakfast and take a shower and stuff like that, but I'm intending to do, like, a pretty long stream. And I know that's not typical, but, give it a little angle. Yeah, that's what I'm trying to figure out. So let me go ahead and... dang it, I'm going to have to open it up again. So let me go ahead and move this over here, move that over there, and let's talk about what we're doing here. So we have some sort of matrix transformation, which is going to be A, B, C, D... of x, y, and then we're adding some sort of offset on the end. So let's go ahead and do this. So it's going to be a of x. So x is going to be equal to a of x plus b of y. And y is going to be equal to, oh my gosh, what am I doing? Y is going to be equal to c of x plus d of y, right? So what we've been doing is to rotate the system. Usually when you rotate a system, you've got like... Oh, what is the rotation matrix? Holy cow, why am I not able to do this? For school, we usually use ppm pixel map format to plot stuff, like Mandelbrot. Oh yeah, this is fair. But this is also a different thing. Like this is, if we're outputting an image directly, you know what I mean? But ppm is a good idea, undoubtedly. To my surprise, LibreOffice was able to interpret it Yeah, LibreOffice is actually impressive in a lot of ways. I know a lot of people, like, they say it's like the crappier Microsoft Office, and in some ways that's true, but I do think that LibreOffice has some advantages. Let me do rotation matrix. And let's see what we got here. I think I just screwed up in what a rotation matrix looks like. So it's cosine, negative sine, sine, cosine. All right, so if we want to, rotate this leaf, how are we going to do that rotation? Again, it's usually cosine, negative sine, sine, cosine. I pretty much don't use Microsoft Office anymore. Yeah, I mean, neither do I. Yeah, we can do sine x, cosine x. Like, that's one way we can do this. But I'm not sure. My office is Microsoft Office is in a different league, to be honest. Yeah, this is the thing. I don't know how or why, but this is what everyone says. And it's one of those things that I don't understand because I haven't been using Microsoft Office forever. So now, like, the current Microsoft Office is completely unintelligible. Like, I have no idea what's happening. Can't you rotate your starting point how much you need to? Yeah, so the issue here is that I'm not rotating a single point, right? Like, I'm rotating a line. So the issue here is that we're taking, like, a random point, you know? And this random point is just like, we're moving this random point in some direction, right? And so we need to find the transformation that allows us to kind of rotate and tilt, but move and tilt. But I don't know if a rotation is exactly what we want here, right? Because, like, we're actually performing a transformation on this object. I don't know. We have to figure it out. Do you mean Office 365 is trash? Do you mean trash 365? Or any simple editor in LaTeX? That's what I usually use. Have you already had some angle when you started stream? You had some waves tree? Yeah. But what I'm looking for isn't the angle of the tree itself. Like, so I modified this so it goes straight up because, again, we're trying to create something that looks kind of sort of Christmas tree-like. What I want is to modify the angle of these individual leaves so they're slightly up a bit more. That's what I'm trying to do here. And so right now we kind of have something that looks a bit Christmas tree-like. Don't get me wrong, it's okay, but it's not quite what I wanted. Is this Julia? Yeah, I'm using predominantly Julia for this code. Let me see here. So if I change this to -3.5, positive 3.5, so let's just change this to 3.5, 3.5 here, same thing here, 3.5, 3.5. Let's go over here and let's just run Julia Barnsley.jl. Give it just a second to run. We're plotting a couple hundred thousands of points. New plot Barnsley. Yeah, so again, we're getting this kind of, it doesn't look bad. Don't get me wrong. It doesn't look bad, but, like, it definitely is too fat to be a Christmas tree. You know what I'm saying? I was just noticing today how similar Emacs and Visual Studio Code are. Are you high? No, I don't think so. I don't know. I mean, Emacs is a wonderful operating system, just lacking a decent text editor. I do understand, you know, some people really like to have their Emacs operating system and everything working, but I don't know. Sometimes you just need a good text editor like Vim or VI. Okay, so what are we going to do here? So if you guys remember from yesterday's stream, they just seem kind of similar to me. I do think they are quite different, though. I think that it's very hard to relate the two and say, hey, this one looks a lot like, you know, in the fact that they're both editing text, you know, although that's probably just because I have them both set up very similarly. Could also be. You can set up Visual Studio Code to basically work however you want. Okay, so let's see what we're going to do here. We have these offsets here, but that doesn't seem to be exactly what we want. So I'm going to go ahead and do this matrix multiplication over here. We say x is going to be equal to ax plus by, and y is going to be equal to cx plus dy. So what we're going to do then is if we want to change the y location, we actually want to change the x location so it doesn't go as far out, right? So the new x location is going to be equal to the previous y location plus the x location there. Come on. How does this work then? So we want then to lower the x location while increasing the y location. Now I've got a feeling, so the previous y location is going to be dependent on the new x location. So let's try something then. What I'm going to do then, is we want to make the Y location higher, but the X location a bit lower. So let's go here and let's see what happens. So I'm going to drop this to 3.0 and drop this again to 3.0, but I'm going to increase this. So this means that these guys are, no. I want the X location to be a bit further out. So let's increase this to our 4.0, and same thing over here. So this can be 4.0 and this can be a 3.0. And this basically means that, what does this mean? So this means that based on the Y location of our object, so this should do something similar to what we're looking for. Let's go ahead and include barnsley.jl. And let's do a new plot. Yeah, okay, maybe it's getting closer to what we want. Control C. Okay, so let's go ahead and drop this to 2.0 here, and 2.0 over here. And then we're going to drop this to 1 and drop this to 1. And again, we can always just grab the previous code with a git checkout, so I'm not too worried about messing anything up here. That is one advantage of version control. Whoa, what did I do there? Okay. That wasn't quite what I was expecting. All right. I mean, if we rotate these super far upwards, like, it wouldn't be that big of a deal. Okay, I have no idea how these transformations work then. A lot take us too much, at least for me, but LibreOffice works decent. And for Git and other kinds of document writing, Markdown files are pretty intuitive. Yeah, that's fair. Markdown is okay. Like, again, we're using it for most of the algorithm archive stuff, simply because when we were initially deciding how to do this, I really wanted to use LaTeX. But the thing is, I couldn't use LaTeX because people said it had a high barrier of entry for other people. And so we kind of decided to use Markdown instead. And don't get me wrong, I don't think that was a bad decision, but I do genuinely like Markdown or LaTeX for a lot of things. And I find it sometimes super unintuitive to use Markdown for a lot of the things here that we're using, we're doing the algorithm archive with. Let's go ahead and do a Control C here. Okay, so I think then what I need to do is change this back to what it was before, which I believe was 2 and 1.5. Something like this. Go ahead and write that, and let's try running this guy. Barnsley.jl. Did you finish the Barnsley Fern? Kind of. We're still working on the Barnsley Fern. New plot. See, here's the Barnsley Fern. We're just kind of messing around with it. I have no clue. I use Java, and Java already has a function named rotation that allows me to rotate. Wait, you use Java to create the Barnsley Fern? I find that somehow a bit weird, but fine, fair enough. So what I'm going to try to do then next... What do I want to do? I'm not sure how to do this exactly. I mean, this does look Christmas tree-like. It's just not what we want. All right, let's pop over here, Control C. What I'm going to try to do then is increase. So it's going to be C is going to increase the X value. A is going to increase the X value. B is going to increase the Y value. Now, what am I trying to do here? AX plus BY is going to be the Y values. So the first two guys will manipulate the X values. The second two guys will manipulate the Y values. So if I want to increase the Y values, then what I'm going to want to do is increase these 2 points down here. So let's try increasing this to 3.0, and increasing this to 3.0, and seeing what this does. Again, we're just doing small scale manipulations here, just to see what's going to happen. And let's just go crazy here, and let's change this to 5. Whoa, look at that. I don't think I've ever been this crazy in my life. Somebody stop me. Please don't, I don't know what I'm doing. New plot. Okay, so this seems to be doing stuff. Like, the tree is certainly higher. So now we want to drop the X location a bit. Oh my gosh. Let's drop the X location a bit. So we're going to change this to 1.5 and this to 1.5 again. And let's do Julia. I'm sorry, this might be a super boring stream. I'm just like manipulating numbers to see what we get. New plot. Now, one thing I want to do, let's do Control C. Let me just pop over here. If I just look up Barnsley Fern, there is a modification of the Barnsley Fern, but it doesn't look... Let me see if I can just... I'm just going to Google this. Christmas tree. I know this is cheating. I know this is totally cheating. But, like, give me a second. It'll function in Barnsley Fern. Barnsley Crafter. Has to be what we're looking for here. No. Don't tell me. The Barnsley Crafter has nothing to do with the Barnsley Fern. It's just some person who's making crafts. Man, that's really disappointing. Nope. Construct a knife as for a Christmas tree. No. Come on. One of these has to... Nope, not quite. No, none of these are super Christmas tree-like, though. That's the thing. They're just slightly off. Ever so slightly off. Let's see, my program creates... Oh. Okay, here we go. Let's see what we got. That's not bad. Yeah, there we go. This is what I'm looking for. I should just copy this guy. But the thing is, this looks like he's superimposing two trees on top of each other, and it also looks like there's some sort of random variation of the... interesting. What do we have? Whoa, dude, have some self-control. Let me see. No matter how good you are at any language, you still have to look at the basics. Yeah, that's totally true. It's one thing I linked a few days back. Wait, what did you link? Oh, wait, yeah, I'm not sure. Okay. So let me see what this guy does. He says, for explanation of how to construct the iterative function system in SAS, each row is a 2x2 linear transformation. Each row is a 2x2 linear transformation. Okay. Yeah, okay. Okay, I'm not sure exactly what he's doing here. He has this set up in a very unusual way. What language is this even? I can't even... Yeah, I have no idea what language this is. Let me see if I can. Iterative function system. The main programming details are that the Rangan subroutine... I can't even tell what language this is. Holy cow. The do loop. I just... This has to be some sort of weird... Like, his notation makes me think that this is somehow Fortran, but it is certainly not Fortran. Let's see. It's SAS IML. Oh. Oh! I didn't know that was a... Yeah, okay. Then I have no idea what's going on here. It's for statistics. Fair enough. A few Christmas tree. I never had the Barnsley Fern before, but I did do a fractal tree, and I could rotate the branches of that. Oh, interesting. Yeah, I don't know what this is. I don't think I've ever seen this language before. You said it's used for statistics. I guess that's fair. So let's see if we can find the difference then. I mean, sure, it's code, right? You can modify it. You make it look like whatever you want. Okay, so here's his transformations. These are similar to the transformations that I had. And here he basically put them each into a row. Yep, okay, that's fair enough. So he has a whole bunch of rows here, and then a translation vector associated with each row. So basically what he's doing here is he has 1, 2, 3, 4, 5, 6, 7, 8. So he has multiple transformations here, and it looks like he has a probability of going into each of these guys. Ah, I see. So he has a probability of 0.2, 0.6, 0.1, and then a bunch of 0.7s, 0.07s here. So I guess what's happening here is he's got multiple... Yeah, so he's got a few more branches, is what he's got here. Would be a cool quiz. What's that language? I think at some point, like there's so many languages out there, you wouldn't be able to answer the question appropriately. Looks kind of pseudocode though. Yeah, so I think I understand what he's doing here. So basically, instead of just having 4 potential branches, he's got 8 potential branches. And each of these branches do slightly different things. And so rather than moving up with an 85% chance like we normally do, he's moving up with a 60% chance. So this transformation that moves forward has a 60% chance. And then creating these different branches, he basically has 4 branches instead of 2. And this allows him to just kind of move up with a slightly more, I guess, a slightly denser tree. You know? And so we could create something like this pretty straightforwardly. I'd love to see that as a game show. I just got a feeling it'd be hard. Adding one of the 20,000 golf programming languages. Yeah. It would have to be ramping up. Let me get some water again. Okay, so we can definitely do this. This wouldn't be too bad. Yeah, it wouldn't be too bad. I think we can definitely do this. So what I'm going to do is I'm going to check out the previous version of the Barnsley Fern that we had, and I'm just going to implement this version of the Barnsley Fern that's here. So the Barnsley Christmas tree. So just so we have it in a separate function and we can start manipulating it and doing all this kind of stuff. Then the hope is that we have a Christmas tree-like thing that we can kind of work with. But the thing is, yeah, I don't know. We need to think about this a bit more. That's okay. CodePen, what do we have? Found this. Open link. What is this guy? Come on. Ooh, look at that. Super nice. Yeah, I think they're doing the same thing that we're doing. I'm like 90% sure. Yeah, here or what the other guy did. He's got the 4 different rows. In fact, this might be the same matrix. It is not the same. Oh, no, it's not the same matrix. It's a slightly different matrix. And then you just added balls on top of it and added snowflakes that are falling down. These are all doable things. Like they're not difficult to do. What is a fractal? That's a good question. Thanks for asking. So a fractal, this is actually one of those definitions that I don't really have a good grasp on, which again is another reason why I really want to write the algorithm archive chapter before making a video on this. But a fractal is something that kind of shows self-similarity. I know that 3Blue1Brown made a video on this, and colloquially speaking, anything that has like the same structure repeated again and again and again and again, this is kind of fractal-like, right? So if you zoom into like a regular fractal, you'll see, just Google fractal. Fractal. Okay, you zoom in to a fractal and you get more of the fractal. That's kind of the thing. So like, is anything that's like, you know, you see more of the fractal the more you go in. A self-repeating shape, not shape, something like this, yeah. So like, it's actually defined slightly differently, and this is something that I don't really have a good mathematical definition of. And it is something that I need to kind of look into a bit more. So again, that's kind of why I wanted to take a step by. And here's like a fractal flame, and this is kind of what we're working on now. We've got several fractal flames that we can make, and it's pretty good. A snowflake is a fractal. Is it? I mean, the Koch snowflake, I don't know how to pronounce this. Koch snowflake. This is definitely a fractal, I think. Wait, one second, is it? See now, yeah, it has to be a fractal, right? Yeah, or at least fractal curves, yep. So this guy, I think, is considered fractal, but I don't think in general snowflakes are considered fractals. There definitely are 3D fractals that exist. This is certainly a thing. It's just most of them are done in 2D just because it's easier. But yeah, so fractals are like these kind of self-similar things. So we've got the Julia set. We've got a bunch of things that we can do. What I'd like to do is spend some time thinking about how we are going to write this chapter on fractals, because again, there's a lot of stuff to cover with fractals. There's just a lot of stuff. So let's go ahead and get this this Christmas tree drawn just to say that we did do it. And then we can kind of work from there. The snowflake approaches a fractal in the limiting case of iterations. Yeah, wait, a general snowflake or the Koch snowflake? Let's go ahead and do get checkout. Get checkout. All right, let's go barnsley.jl. And let's go into vi barnsley.jl. Okay, so I'm just gonna go ahead and basically copy this Barnsley Fern function here, and we're just going to create a new one that's for Christmas trees. So we're going to say Barnsley tree. Yeah, we'll do tree. Why not? Let's go. Okay, so basically here we have a few additional transformations that we're adding onto our system. And we're going to output this as Barnsley tree .dat. Why not? Let's go. Okay, so here we just modify this so that we have a few more if statements and basically a few more branches that we go into and go from there. Fractals are basically never-ending patterns, you could say. Yeah, in principle, yeah. They're patterns that as you zoom in, you see more and more of the same thing. All right, so let's go here and let's just go ahead and copy this a few more times. So we're going to yank to yank. We're going to paste, paste, paste. All right. So now we just basically put in the transformations we need with the appropriate probabilities, and we can just follow this guide that this guy has over here. So the first transformation has a 0.02 probability of entering this particular branch, and the transformation itself is going to be 0.0300.01. 0.03. And then the last one's going to be 0.1. Okay, so that's the first transformation. Let's go. Now we only have 7 more to do. So the next transformation is 0.85, 00, 0.85, 0.85, 00. And this is exactly the transformation we tried to create before, so I'm pretty happy with that. And the offset is 1.5 instead of 1.6. All right, now this guy only has a probability of 0.6 of being entered into, so we need to change this so it is now 6.1 instead of what it was before, 8.5. And I think what I'm going to do is I'm just going to go ahead and shrink this guy a bit and move it over here. Yep, okay. So this will be right over my face, so I can see it easier and we don't have to keep popping back and forth. Okay, so this is that transformation. The next transformation has a probability of 0.1. So this is going to be between 6.1 and 7.1. All right, and its transformation is going to be 0.8. Let's see, 0, 0. So let's go ahead and change this to, ooh, hello there. This is going to be a 0, 0. And then the last one's going to be 8.5. Oh, I'm sorry, 8. Okay. And then this guy's going to have 1.5 similar to above. All right. So basically what we're saying here is we have a large transformation, a most likely transformation that's going to move our object that we're creating up. But we have another transformation that's going to move it up, but with a slight variation. So it's going to be slightly down a bit. So more than likely, we're just going to be moving up. But there's also a slight chance we're going to be moving up slightly less. Does that make sense? Stupid bug. Okay. What do we have here? You can zoom arbitrarily close and always have just as much details when you started. Yeah, this is basically it. Let's see. I think of them as sorted as a sort of recursive shape. Maybe you need code refactoring. Yeah, probably. I almost certainly do. Great Britain or any continent would be a fractal because no matter how far you zoom in, there's always a curve. Actually, so this is what 3 Blue 1 Brown's video was kind of talking about a while ago. So he specifically did mention that fractals, whether the fractal notation is kind of meant to be like some sort of depiction of the topology of the object in some form, you know. And this is something I do need to relook at the video. It's been a while since I watched it, but it is very interesting to look at. So he has a video on fractals that I would certainly recommend checking out. It's pretty good. Hey, Lick, how are you? Wait, what? Country. Okay, let's see. There's no requirement of self-similarity. I managed to install 2 programs at work in 12 hours. Dude, that's way more programs that I've installed in the past 12 hours, so you were doing pretty well. Good job, man. All right, so let's keep going. So the next probability, let's see, so we're on number 3, so now we're going to move to number 4. This changes a bit, so this is now going to have a probability of 0.085. Oh, I'm sorry, am I doing this right? No, there's a probability of 0.07. So let's see, it's going from 0.71, so we're going to start at 0.71, and then it's going to go to 0.77. All right, the transformation is 0.2, negative 0.08, 0.15, and 0.22. Nice, so the next one again has a 0.7 probability, so it's going to be going from 0.77 to 0.84. All right, and this is going to be the transformation of negative 0.2, 0.08, but I think this is a positive. Yep, 0.15 and 0.22. good. The next one's gonna have a probability of 0.84. And it's gonna be 0.7, so it's gonna be 84291. Did I do this right? Does this add up? 0.6 plus 0.1 is 0.7. 3 sevens gives you 0.28. I screwed something up, didn't I? All right, this is the probability of 0.02. This is the probability of 0.0. Ah, that's a 2, which means this is going to be a 6.2, and this is going to be a 7.2. Yep, screwed something up. 7.2, so this is going to be a 7.8. This is going to be a 7.8. And this is going to be 8.5. This is then going to be a 8.5 to 9.4. Something like this. I'm definitely doing something wrong, but it's okay. What do we have here? Did you try and install some Linux apps on Windows? Wait, what? I think I'm turning ball from installing VM Cloak and Cuckoo. I don't know what Cuckoo is, but I feel like VM Cloak, that has to be some sort of virtual machine, right? I got the book, The Little Shemmer, and it's the best book ever. Huh. Interesting. I also have never heard of this. No, but the programs actively refuse to be installed. Yep, I know that. Actually, twice each. Did you try installing some Linux apps on Windows? I guess you shouldn't try to install 5 at once. Then you would have to install them 5 times each. Yeah. Yeah. Okay, so did I get this one right? So it's 0.02. Then we go from 0.02. 1 second. To 0.62, 0.62 to 0.72, 0.72 to 0.7. No, I still did this wrong. 7.2 to 7.9. There we go. Okay, 7.9. How did I do this so wrong? 7.2 to 7.9. Okay. 7.9. Alright, then this is 8.6. 8.6. Here. Then 8.6 goes to 9. Oh, 8.6 plus 7 gives you 4.93. And that's what I'm looking for here, 9.3. Okay, is this transformation correct? So it's going to be 0.25. Negative 0.1. 0.23, so this is going to be 0.12. And 0.25. And then the last one's going to be down here, negative 2. Oh, that was, you need to keep the negative there. 1. Let's see, 0.12. And the last one, 0.2. So now let's get all these offsets right. It's going to be 0.15, 0.15, 0.85. $8.5 down here too. And then we're going to have to do 0.3 and 0.4. Okay, so this should be correct. So if we pop down here and we do yank paste and turn this into Barnsley tree, we should see the Christmas tree being generated. Okay, so let's pop over here. Let's run this guy real quick. Hello, come on. So we're going to run include barnsley.jl. And then we're just going to try plotting that guy. So let's go into vi plot. Well, let's just go ahead and copy this. So we're going to cp plot barnsley.gp, and we're going to copy to plot Barnsley tree. GP. And let's go into that. Plot Barnsley tree.gp. And this is going to be Barnsley underscore tree. So we're going to do new plot. 1 second. And then we're going to do plot underscore Barnsley underscore tree.gp minus, and we should see, yeah, that kind of looks a lot. I mean, that looks a lot better. Undoubtedly, it looks better, but it still looks too thick, doesn't it? What do we have over here? Virtual machine cloaking, automatically cloak virtual machine, making them harder to detect through usual ways. Yeah, there is a, okay, look, there is a better way to do it than a bunch of if-else statements. That's undoubtedly true. The issue is that if we do this with, adjust your axes. Yeah, we could make the axes. Yeah, I see what you're saying. The issue is if we do this, shame it's so hard to install. Yeah, so there definitely is a way to do this without a bunch of if-else statements, and we can think about that real quick. So the issue is that like each of these branches has a set probability to be found, you know? So like, how do I put this? Like they, like the first one has a probability of 0.1, the next one has a probability of 0.2, so on and so forth. Yeah, it is clearly stretching to fit the canvas. That's true. I can modify this real quick. So let's go ahead and do a Control-C over here, and let's just look at the script that we have here. And what I'm going to do is, what is it? It's set X range, and we're going to set this to native to 2. I believe this will do it. So let's try that. Yeah, okay. So I just doubled the X range, and it clearly makes it more Christmas tree-like, which is nice. Let's go ahead and change this to 1.5, 1.5. Control C. 1.5, 1.5. So new plot. So that looks pretty good. I mean, I'm a fan of that. I mean, don't get me wrong, it's not fractal flame, it's just fractal, but it's fine. What happens if you superimpose another Barnsley fern on top of it where the branches are pointing more downward? I'm honestly not sure. I don't know at all. So what we did here is we kind of superimposed two ferns together. So we added in an additional transformation that basically made it so we have like an additional branch before it's copied sequentially upwards. So what we're doing here is we're basically taking this structure down here, right? And we're taking this structure and we're basically copying it sequentially upwards, right? So what we did is we changed this transformation down here such that it now has two branches down there. So it looks kind of a bit more random. And then it's kind of brought upwards from there. There are no lights. He's coloring each step of the fractal drawing. From my understanding from the beginning of the stream. Yeah, that's exactly what I'm doing here. So we're having about 1 million points that we're plotting here. Well, no, how many points are we plotting here? 10 million? No, it's 1 million points. And I'm plotting in batches of, I believe, 100,000. 10,000. So I'm plotting in batches of 10,000. So that means we're just continually plotting again and again and again. But it looks like lights. I mean, I'm not going to lie. That's one of the reasons I wanted to do a fractal Christmas tree, because it's relatively, like, it looks a lot like a Christmas tree. Pop over here, Control C. Let's move this back over here to this desktop. Okay, so as far as the if-else statements are concerned, yes, there is probably a better way to do that. Let me just, I'll keep this up on the side and we'll take a look at the code. So here's our little Christmas tree. It's not bad. You know, it's not bad for an attempt. Okay, I know it's not anywhere near as like cool as we wanted it to be, but you know, we're getting there. Okay, so as far as the if-else statements are concerned, again, what we're doing here is we're bidding basically a random number into a bunch of, into a bunch of bins, right? So we say if it's under 0.01, you know, we do this. If it's over this, it's just a straightforward way to say, you know, we have a 60% probability of falling into this bin, you know, which means we have a 60% probability of doing this particular transformation on our Barnsley fern. And it's a nice way to think about it. Now, there are ways to think about it that, you know, maybe are better programming wise. The issue is that this kind of obscures what it is that we're actually looking at in some ways. But yeah, there's probably a way to get the best of both worlds. I just hadn't thought about it. I just do a whole bunch of if and else if statements and stuff like that because it's easy. We can randomly select between an integer with some sort of probability. So we give it maybe a set of probabilities. And then we just... yeah, I don't know. I need to think about that some more. Okay, so we do have a Christmas tree kind of being generated. That's nice. I'm a fan of this. I think it looks pretty good. Let me go ahead and get some water. So the thing is, if we do the fractal flame Christmas tree, we are almost certainly not going to be able to do this type of colorful animation with it. And I'm honestly not sure how we want to improve on this Christmas tree if we add the fractal flame method to it. So let's go ahead and talk about, so I think we've gotten a few Christmas trees provided to us. I think one was actually provided by C252. Another was provided by Folster. So let's go over here and let's control C. Let's do a quick ls. And I think CD and images, ls here. Oh, that's not what I wanted. Where is it? ls here. Oh, where did I put that image? I don't know where I put it. CD tree, maybe? ls here. Oh, here's Folsters. So if we do an mirage of Folsters, the PNG. So he created this fractal Christmas tree, which was really kind of cool. It's a bunch of Sierpinski triangles kind of put together via the fractal flame method. And I think it's pretty cool. I'm a fan of it. And what I was thinking about doing was basically mixing a bunch of these kind of flames together, a bunch of these iterated function systems together, such that we can generate a, oh, how do I put this? Such that we can generate something kind of like this, but, you know, with the Barnsley fern instead of the Sierpinski triangle. I just don't know. Oh yeah, for some reason Google keeps giving me notifications telling me that traffic is high or heavy in my area. But I don't understand how it's heavy in my area. It's 6:17 in the morning. Like, are there people outside? Just like, I don't think there are people outside. Let me see. No, it's too dark to see anything. Like, I can see nothing outside right now. So like, there's no way there's traffic in my area. Ah, Google. Okay, anyway. So this is what we have here. I think it's quite good. I'm a big fan of this. Now, the issue is, if we're not getting a video out tomorrow, the Christmas tree theme doesn't really make that much sense anymore. So we need to kind of think about what we're going to do from there. The Coke Snowflake. Yeah, so the Coke Snowflake, I think it's generated in a fundamentally different way. So the Coke Snowflake is generated via, like, I'm sorry, via fractal curves. You know what I'm saying? So the fractal curves are different than the iterative function systems. You know what I mean? It's sports game. Could be. So these fractal curves are way different than the iterative function systems that we're using here. Also different than the chaos games, right? So this is a bit different. I don't know exactly how to generate a pulsar. Because I always thought these were huge. Yeah, okay, so I don't think I can generate this because this is what I was thinking. This can't be what you mean by pulsar. Right? Because I don't think I can generate this. But maybe. Oh, actually, no, it'd be possible. Let me see. Pulsar is a highly magnetized rotating neutron star. Yeah, I have the simulation to do this. Like, I have Coke Snowflakes, I see. Am I mispronouncing it? Let me see. Maybe I am mispronouncing it. How do you pronounce this? It's a fast spinning star. Oh, then yeah, I technically can do that simulation. Yeah, I definitely can. I don't know about you guys, but I find, okay, I'm gonna probably shoot myself in the foot by saying this, but I do tend to find space stuff a little bit boring. Like, don't get me wrong. Like, I used to study supernova remnant plasmas. So I mean, I used to at some point do kind of like this type of stuff, but no, it's German for cook. The CH is a weird sound. So is it Koch? I don't know, man. I'm so sorry. But anyway, like, I used to study supernova remnant plasmas, and it's fine. But I think that there's this weird fascination with space and stuff that it's just weird. I don't understand. Like, why people enjoy, like, just studying space is just weird to me. Like Heckler and Koch. Yeah, yes. So who's right? What are we talking about now? I'm super confused. What is the correct pronunciation of this word? Is it ko or cook? I don't know. You actually kind of got it? So koch? I don't know. I'm very bad with my pronunciation. I'm just gonna call it the Koch. The Koch snowflake. Koch. I can't do it. Keep it the main. I don't know, man. Let me just Google how to pronounce. How do you pronounce the name? It's pronounced Coke. Okay, but I think this is a different type. I checked on Google Translate and it sounds like Koch. Okay. Maybe. How to pronounce Koch? Koch. They're saying Coke. They're definitely saying Coke. Oh, but look at the like to dislike ratio. Oh my word. I've got a feeling. Oh my gosh. They're saying it's a German name and word, and that's not how you pronounce it.
Coke.
They're definitely saying Coke. All right, fine. All right. Okay, it's pronounced in a German like Koch, cough. Named after a Swede, triggered in German. I'm so sorry, guys. All right, I'm gonna call it the Koch. Okay, so Koch, the Koch snowflake. Is this okay? Koch. I don't know anymore. We're just gonna call it the fractal snowflake, just because that's easier to do, and we're not gonna worry about it. All right. I'm sorry. I'll try to figure out the appropriate pronunciation. As far as the pulsar stuff is concerned, I was planning to do a galaxy simulation at some point with the Barnsley-Hutt algorithm, and so in principle we can do that. How about the snowflake fractal? You're talking about, so the snowflake fractal, we can do this one. Why don't we call it Billy? Billy the snowflake fractal? Oh, I'm so sorry. I'm so ignorant of other people's pronunciations and cultures and stuff like that. Anyway, that's easier to say. Yeah, so I think in principle, we could do something like this. I don't see anything wrong with it. Whether we should, that's another question. It'll take a lot of time to generate, but we're intending to do some space simulations anyway. The only way I could put it into English pronunciation is K at H. Yeah, this is the thing. I think that maybe there's some sort of German sound here that doesn't translate appropriately into English. So you're saying Koch is German, not sure if it's also Swedish, but in German it means cook. In Swedish you'd say Koch. Okay, the Coke. Yeah, I don't know. Create a double pendulum. I don't think we can create a fractal double pendulum. I mean, it's easy enough to simulate a double pendulum, right? Like it's just a bunch of forces acting on itself. It's not so hard to do. Okay. I am, however, somewhat happy with our little Christmas tree we generated there. Sure, it's not great. Like, yeah, we could do maybe better, but I'm happy with this. I think it's nice. I think it looks Christmas tree-like. It looks like lights are showing up. It's nice. I know it's bad to laugh at others. I just remembered this. The snowflake curve. Yeah, we could do that.
All right. Okay. This is the last one. Let's take review. Do you have cock? Remember cock? It's not cock in Korean. What's cock? Cola.
Okay. I mean, yeah, so there was actually this one girl, like has a pronunciation on Discord. All right, I will take a look. Discord. Oh, I can't get that last character. Call. CH is really hard. I'm not gonna be able to get that. Oh, there's no way I can get that. Call. It sounds like you're saying core, but with a CH. Koch. I can't do it. I'm sorry. I'm gonna try. I will try, but I can't guarantee I can get that. Similar to our discussion on Koch. I haven't heard that in ages. It's Koch. What is this weird text to speech? Just say Koch. Yeah, I'll try. I'll do that. Sorry about that. So anyway, as far as our fractal Christmas tree is concerned, I'm actually genuinely happy with this fractal Christmas tree. I think it looks pretty good. Sure, we can add like lights and stuff to it, but honestly, I like this. I think it's nice. I think, I'm happy with this. I genuinely am. So what I want to try is just basically turning the background to black. So let's see, new plot. And then actually, I think I'm pretty happy with that. Background color. Set terminal to PNG. What I want to do, let's just try fill black. So we're gonna do vi plot Barnsley tree.gp, and we're just gonna try. Can we do fill black? Is that allowed? Well, let's see. Nope. That's certainly not allowed. Okay, set terminal PNG, and then check the output of the new plot. Let's see. Set border color, title, set our text color. Set object 1, fill style solid 1.0, fill color RGB color black. Set object rectangle from screen 00 screen 11, fill color RGB green. Behind. Okay, so what if we just do this? All right, let's go. That didn't work. Set object 1, fill style. So what was the error? Dagnabbit. What I would do is use 2 for loops to create each pixel black, then do the tree. Yeah, this just take forever to plot. So there is a way to create objects in new plot. I've done that before. So saying unknown object. So it says set object 1. Oh, I see. Maybe because I didn't create the object. Yes, that's what I need. So set object 1. So we're creating the object 1, and then we're putting it behind the screen. So let's just take a look at this guy. So we're going to open this guy, create our object 1, which is a giant rectangle. And we're just going to do... Ho ho! Ho! Look at that now. That doesn't look so bad. Except for the random black dots every now and again, it actually doesn't look so bad. Yeah, okay. I'm a fan. And I realize this isn't a fractal flame. I get that. But it's not bad. So now all we have to do is set this to like some sort of like terminal PNG, so it outputs the PNG images, and we just put them all into a single image, and then we're happy. I'm actually like, or a single GIF or something like that. I'm actually genuinely happy with this. I think it looks kind of nice. So now the question is, do we make a video tomorrow? I'm done with this, man. I'm not adding a star. It's so hard. Yeah, okay, so fine. What am I going to say here? Foldster did the fractal flame method. It turned out pretty well. Yeah, that's fine. Let's see, can't you prevent that by increasing the minimum on the R&D? I don't know what you mean. Can't you prevent what? Partner finishing up your report away from the holidays? Let's see. How are you? Let's see. Yeah, so what do you mean by increasing the minimum on the R&D? I'm genuinely happy with this. I think it looks okay. I mean, yeah, it's maybe not the coolest Christmas tree around, but it's pretty good. I still like to make a tree. The color? Oh, the color that's turning into black. I can take a look to see what we can do with the color. I think, though, the way that I'm doing this is, let's go here. So let's go quit here, vi plot, Barnsley, tree.gp, no title, point type 15, point size 0.2. Hey, it's better than my tree. Your tree was cool. It's like a video too. I liked that. I'm also pretty sure I found a project that I will work on over the holidays. Mine's super boring. No, yours is the one that was doing this thing, right? Okay. So here's the thing, though. This goes back to the schedule argument. I have this goes back to the schedule argument we had before, right? Let's go to Control D. marsleytree.jp. Yeah, I do like this tree. It is a nice tree. It's not bad. Okay, anyway, point is, what I was going to do is hold off on the tree thing. The thing is, I can't just make a video on fractal trees now. I could try to rework the video so it's entirely based on creating trees with code, which would be fine. I don't know if I can get it out tomorrow, though. Wait, it's a bad one, I'm gonna cut you down? If it's a bad one? Actually, I'm very interested. What is a tree? For a joke tree. So you're going to create a tree that is itself a joke. The next order prediction for an Instacart dataset. Okay, wait. How many people actually sent me trees? So I know Foldster did. I know C252 did. But who else sent me trees? Because I think we only have like 2 or 3 submissions, you know? Yeah, I think we only have a few submissions. But I might be missing 1 or 2. I don't know. So I guess I'll post on Discord over here real quick. What do we have? Where's Discord? There it is. Let's see. I need to... Okay. Here. Okay, I'm waiting. Okay, so ultimately I'm okay with this. So now the question is, what do we do with this? So we have a few trees. We've got one from Folster, one from C252, one from, well, here's one from me. I just don't know how many other people have the trees. This photo of actual tree. Okay, yeah, nice. It's not Christmassy, but it is a tree. Let's see. It's an old Kaggle contest I wanted to do, but didn't have time to. Best models were huge stacks of gradient boosted trees, and want to see if I could beat that with neural nets. Oh, interesting. Yeah, there's a way to... This is basically... Is this a Sierpinski? No, this is slightly different. Huh, interesting. Built on Code Studio. View code. Let's take a look. Oh, I'm sorry for the yawn. Oh, I'm so tired. I'm always so tired. Why am I always so tired? Whoa! Is this like Scratch for adults? Huh. My tree open link. Oh, that's wonderful. That is wonderful. Okay. I don't really comment it. Oh, it's fine. I don't think I've ever seen this type of code before, though, so I just didn't know what it was. Huh. I didn't know what it was. Holy crap, yours is way more impressive. I don't think this is Scratch exactly. This is... I don't know what it is. Studiocode.org. Yeah, I don't know what language this is. How long did it take you to do? But it's based on the power of 2, and you can change it by tuning angle. You can increase it and decrease its fatness. Tuning angle. Oh, with this is point x direction tuning angle. Change this to 60. Oh, what? Can I not reset? Hello? Okay, let's just, okay, can I modify this? Do I have to remix it? Oh, I don't have an account. All right, let's get off that. It's fine, don't worry about it, it's not a big deal. I understand why it has to be view only. It's totally understandable. This website uses mainly JavaScript for their block programs. Maybe you can clone it. Yeah, I could potentially. I tried to remix it, but it's fine. It is what it is. I understand that you can modify it. It's cool. So it's based off the power 2. You can change it. Okay. So question. what are we doing? The answer is I don't know. I can potentially make a video out tomorrow, but again, I wanted to kind of wait a bit on the video because the video I just don't feel comfortable putting a video out on fractals without the chapters in the algorithm archive for fractals. This is perfect. This is perfect to put into the algorithm archive, and the fact that we're not doing it is just a huge oversight, I think. And so I think, on the one hand, I do really want to have these fractal Christmas trees up. Like, I want to talk to people about it. But on the other hand, I feel like we need the algorithm archive content too. And we didn't get too many tree submissions. We got a few, but not that many. And so I feel like it's okay to wait until the fractal video to say, hey, we made our fractal Christmas trees, make a teaser video for fractals with the trees in it. Yeah, we could do it. And that's kind of what the plan was, you know? So this entire script is basically describing like how the Barnsley fern works, and then an in-depth video later. Yeah, this is kind of what the video was meant to be. Right, so basically it's talking about like ThinkerCon, explaining like, hey, we created the Barnsley fern during ThinkerCon. It looked kind of like a Christmas tree, so we turned it into a Christmas tree. But then the thing is, I can't really adequately describe what the Barnsley fern is without really describing the Sierpinski triangle, so we need better animations. Oh, I don't know. Let's see. Then you can make a longer video about fractals later. I can. It's only Christmas once a year. That's true. Java has all the programming. Let's see. Java isn't the best language, but it's easy to understand and good introduction to coding for new people. That website is trying to get more people, mostly children, into coding. Yeah, I understand this. Similar to Scratch. All right. To show fractals. So the major objective here is just to... Yeah, I think the major objective here is to show how these iterative function systems work, you know? And I think that if we're not showing that in the video, then we're kind of missing out, you know? And sure, we have this Christmas tree that we can generate. We can do these Christmas trees, and I think they're nice. And it was kind of nice to have, like, a few community submissions and stuff like that. But it wasn't, like, a big... It wasn't, like, a big community competition yet. Like, it wasn't as big as I want. So I think the next time we try a community competition, we should really advertise it on YouTube first and say, hey, this time we're going to be doing a community competition, maybe once a month we do, something like that. It isn't. What isn't? Oh, Java is dead. Do you guys have foams? What? Do you guys not have foams? What is a foam? I assume you mean phone. Yeah, okay. I don't have a phone, actually. JavaScript is a chaos-oriented scripting language. Oh, I see what you're saying. You're right. Java is far from dead. It's used all the time in Android. A lot of enterprise still uses Java. Yeah, that's true. Chaos-oriented. Why can't it just be fun? Why can't what just be fun? The video? Oh, no. You're right. It's when I say community competition, I don't mean that. I mean, it's just kind of a fun get-together. Maybe we shouldn't call them community competitions. We should call them community collaborations, community... I don't know what to call them. It's just like fun little things that we get together and just make trees for, you know? It's just stuff like this. And I do want to, next time we do one, I want to advertise it on YouTube, say, hey, I'll be live for a few hours here, just, you know, come, have fun, enjoy the time, something like this. And so I think probably how the schedule is going to work from now on is I'm going to try to put a video out every other week. One video is going to be algorithm archive content. One video is going to be like just community stuff, you know, just like, I don't know exactly how to put this, but something like that. I purposely enrolled in a course that explicitly didn't use Java in the first year. I just don't like Java. I understand that too. Would you call them HFPC? What does that stand for? Happy Fun Programming Challenges? You still have the word challenge. So we could do community challenges, I think. Programming challenges, something like this. I think that's fine. I remember you need an interface to make a lambda, and I think we have a function AB now clear. Cool story, Bob. Okay, so I think this is okay. So I think, you know, we've got our tree. I'm happy with this guy. Ultimately, I think, yeah, we could update it, but I'm happy enough with this. Java, I mean, it is Java still crap, yeah. It's a cool curve based on the distance between prime numbers. Let's open that up. Oh, nice. Yeah, interesting. Again, it's hard to interpret, but it is interesting. Okay, so I think this is okay. Let me go ahead and do a quick, git commit, git push, all this kind of stuff. Put this onto the Simulaos directory, and we'll talk about where we're going to go from there. So git status dot git add. Now, what changes do we have for ifs.jl and plot.gp? Git diff plot.gp. Okay, git diff ifs.jl. Yeah, we can go ahead and add that. Git add ifs.jl. Git add barnsley.jl. Git add plot barnsley tree.gp. Git commit -m. Adding simple fractal Christmas tree. Done. Okay. So we'll go ahead and push this, and we'll talk about schedule a bit. Git push origin master. All right, let's go. Okay, so again, tomorrow is going to be our GPU day. There's no doubt we're going to do some sort of GPU stuff. I haven't decided exactly what we're going to do. Probably maybe Julia GPU or something like that. Let's see. I want to suicide every time I write those one-line getter and setters. Oh yeah, I know that feeling. Getter and setter functions are weird. We should make accounts at codewars.com or something. Yeah, I'm not sure. Well, don't get triggered by having conversation on languages. I mean, we can all agree that HTML is the best language. Yeah, definitely. There's no question. HTML is not a programming language. Please stop it. Nor CSS. Or coding game or hacker. Let's see, programming language though. I don't know. I see people putting HTML and CSS programming language on LinkedIn profiles. Oh, this is wonderful. Okay, so as far as the schedule is concerned, I'm gonna have to kill myself. Like, just metaphorically speaking, it's gonna be really hard to get a video out tomorrow. Like, I can probably do it. It's just gonna be very difficult for me to do. Meanwhile, I think we can put a much better video out in the start of January and just say, hey, we also created these fractal Christmas trees when we were doing it, because this happened a few weeks ago. And I think this is perfectly fine, because I think it's okay to say we did the challenge on Twitch. It was a pretty useful test case, and now we ended up, you know, using, I don't know how to put this, but then we ended up doing it like a fractal challenge and stuff like that. And I think it turned out pretty well. Like, I think ultimately this is okay. Don't kill yourself. I meant metaphorically speaking. Like, I wasn't talking about physically. I'm sorry, I need to stop using that that euphemism. I don't know, I need to stop using that. I need to say, look, it's just gonna be really hard for me to get a video out tomorrow. Fireworks didn't explode, show fractal. That'd be super cool. As a markup language, even if it's named. We also make cool circle patterns on code.org. Let's see. It's not Turing complete. You should create a video asking people to create trees and show it in the next video. Yeah, that's what I'm thinking. I think I just did this one wrong. I think I should have advertised, hey, we're going to be doing this coding challenge together as a community. And then said, all right, so now that we have the coding challenge, then in the next video, we do the next coding challenge. Does that make sense? Like, we basically say, you know, we have these coding challenges coming up, and basically every month we just do a different coding challenge or something like this. And I think that's pretty good. I don't mean that the way it might sound. Yeah, I just wanted to say that we'll see how this goes. I'm going to sleep, guys. All right, see you, Trash Talk. Thanks for coming in. I think this is actually a good place to stop. We have a fractal Christmas tree. It looks pretty good. I'm a fan. And then we can talk about where we're going to go with this on Discord, I think. So I think this is a good place to stop. Let's see, how many people are online? What do we have here? We can host Oh Bother. We can host, who else is online? Stephen Wolfram, we could host him. I think probably Oh Bother would be a good person to bother. I think that's fine. Okay, so we'll come back tomorrow, and we'll do our typical GPU stream. I think what we'll do is probably Julia GPU tomorrow. I do want to study up and learn some more of this. So I think that's a good thing to look into. And I think that's it for the day. Not Oh Bother. Okay, so who do you want to host then? Not Oh Bother, because we do host Oh Bother a lot. Wolfram or Oh Bother? I'm okay with hosting Wolfram. He just doesn't, he doesn't talk too much with the chat. What's the GPU stream? So every week on Sunday, my time, we do a day that's specifically devoted to GPU computing, just learning more about it, this kind of stuff. So we did a few streams on Basic Vector Edition in CUDA and then OpenCL. Then we did, let's see, a few more discussions on, how do I put this? A few more discussions on, here's the Discord link. What was it? Vector reduction, so basically vector summation. And then we did a final stream last week on GPUE, which is a code base that we were working on. So the fern that I was working on is called the Barnsley fern. Okay. So I think that should be it. So we can host Stephen Wolfram. Yeah, that sounds fine. I think that's a good idea. Okay, so unless there's someone else that you guys want to host, but I think Wolfram is fine. Okay, guys, thank you so much for coming in. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you again next time for the next episode of Simuleos when we do something a bit different. Again, it's probably gonna be Julia GPU or something like that. And then the day after that, we're gonna be doing a long stream where we do basically algorithm archive updates, just attacking all of the problems that we have. And go from there. Let's see. I've been meaning looking at GPU computing. I'll be there. Cool. See you tomorrow. You should watch this video for this. What video are we talking about here? Okay. So I think that's it, and I will see you next time. Bye, guys.